Thank you. So yeah, my name is Sören Hollatz. I'm working at Photonics as a product manager, and I would like to talk about advanced process monitoring today with, in this case, focus on laser welding applications because this is the most important part for us, and especially in automotive. So Photonics is a small company located in Isernhagen, close to Hanover in Germany. This year we have our 30th anniversary, so join us at Laser World of Photonics to celebrate this with us. So laser processes and the process monitoring, therefore we have like two main goals that we are dealing with our products. First of all, we'd like to increase the process monitoring accuracy, because having pseudo faults or missed faults is very, very painful, and at the end very expensive in production. And the second goal is that we also like to classify the faults. So having a bad part is one thing, but having a bad part where you know this is the reason why it is bad, that helps you to adjust your production, to maintain your clamping devices or your safety window, let's say optics or whatever might cause this fault. And these are always our goals that we are offering the customer. Therefore, we have introduced a new product, and this is the 42 sensor system, and this whole system is called 4D Watcher. It is based on photodiodes, so we can coaxially integrate it into a laser head. I hope you can see my cursor now. So we can coaxially integrate it into the laser head and acquire the data that is coming from the process. So all kind of light emissions exposed by the process are going into our sensor system, and there we have a couple of different photodiodes catching the laser radiation, the visible range, and also the near-infrared range. And the special thing about this sensor is, and also the difference to our competitors, is the thing on the right side here. We are splitting up the near-infrared light and also the visible light into its spectral components, and have like 16 channels for each of these areas. And therefore we can acquire a lot of data to adjust the process monitoring individual to every process we would like to see. We usually do not need any kind of hardware filtering. We can just say, in this range, like in the red wavelength range, there is the light for our vision system. So we always have this red light from the lamps. And so we just leave these channels out of our monitoring without having any filter necessary there. With this sensor, we're trying to reach a lot of different markets, a lot of different applications. The idea is to have one sensor, one hardware for a lot of different applications, not just laser welding, also laser powder bed fusion, laser cladding. There might be also a picture of a brake disc here on the left. And also ultra short pulse processes and whatever you might think of. So for today, due to the limited time slot, I've brought two examples what we are right now doing, and there I focused on faults which are very difficult to identify with other sensor systems or in visual inspection in this case. The first one is gap detection. So Gwen also introduced that it's no issue with their laser to weld with a gap, but still it's an issue that happens there and which we like to avoid, or at least to detect, so we can decide if we can tolerate it or not. And this is a fault you usually can't see, especially when we're talking about battery welding with a couple of hundred battery cells in a module. You can't see if there is a gap under your bus bars. And there we did a lot of experiments with a couple of research institutes first, and then with a couple of companies. And this one is an exemplary data from an aluminum to aluminum overlap weld, like for prismatic battery cells. And here in the bottom, we can see like the result of one of the welds that have a gap inside. So in green, this is our reference band. So all of our reference welds are the signals of all of our reference welds are included in this green area. So this is more or less the area which is fine for us, which we are tolerating right now. And we are always comparing to these references. So reference is probably good process for us. And this black line here in the bottom, you can see that this one is a weld with a very, very small gap. And you can see that this black line is, violating this red line, which is our lower limit for our process monitoring. And with this violation, our system would give you like an NOK result back for this weld. And you can decide whatever you have to do with this weld, if it's acceptable or not. It is actually not our responsibility. For us, it's just important that the system can see even small deviations that have an impact on our process. Another short example, Gwen has also introduced you the hairpin welding, welding of two copper pins. Here's one main issue that this process can lead to pores inside your hairpins. And this is also a fault type which is very difficult to see with different visual inspection methods or what else you can think of. And as long as you're not going to do a very expensive CT analysis, we might help you with our sensor system. So to make clear, we are not able to directly measure the gap or acquire the gap or measure kind of pore volumes. We can just give you a possibility based on the process. So the process is changing in some way, and we have to match it to the fault which is occurring in the end. So in this case, it's an example from real hairpin stators from a customer of us. I'm luckily allowed to show at least this graph. And there you can see again a green reference band and also this black curve from our weld, which has at the end, they measured it with a CT, has a very, very high pore volume. And we can see here in the first steps, this black line is always more or less inside this green area. So it would have been a good weld until here, process step 4. And there we can see that the signal is going out completely out of our sensor limits. And at the end, the visual inspection said this pin is a good one. But due to the CT analysis, we know that there was a very, very high pore volume. And so we could identify the characteristics of these signals, which lead to a high pore volume. And this helps us to give them an idea which which pins they have to double check or which pins are actually pretty bad, even if the surface looks good. Yeah, that is what we can do and what we can offer you, providing reliable multispectral process monitoring. I've said it also, we have one sensor for more or less any application that has some kind of light emission. And yeah, what you can do for us is we are always looking for new applications, for new laser processes. When there is a challenge for you in monitoring or with some failures in production, we are happy if we can at least try to help you and to prove that our sensor system is very capable of identifying these faults. Yeah, of course, also partners for scientific or industrial cooperation, ideas for future products or whatever is possible. We are open up for this one. And yeah, also that's one good thing at Epic. There's a wide range of companies and also markets, and so that would be nice, of course, to have some new ideas for where we can use our sensor system. So that was a short overview from my side. If there are any questions, I have a lot of more slides, but we are limited in time, so I keep it with this one. Thank you very much.